Okay.
The question we put it up with it.
Okay, so we are making this K-map. What are the 4 inputs? We have S, W, H, and A. S, W, H, and A. And the output says for the output we have a term X. Right? S is that the student is from the senior school. W, height is between 50 and 60 kg. H, height is in between 5 feet and 6 feet. And A is taken part in inter-school athletic meet. Now, we first make the K-map. 0, 0, 0, truth table 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. 1 0 0 0 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. This is the truth table. Now see, the first condition tells that the candidate is from the, so we have S, W, H and A. The first statement says the candidate is from the senior school, means S has to be 1, but and has participated in inter-school athletic meet. A will be 1, W and H will be ignored. Just see here, the candidate is from senior school. He has participated in athletic meet. So S will be 1, A will be 1, W and H will be ignored. Now we look for the conditions 1 and 1. S1, A1. So this is 1. This will be 1. This will be 1 and this is 1. Right? Second condition tells the candidate is from the senior school, means S is 1. But the height is between 5 feet and 6 feet and weight is in between 50 kg and 60 kg. 1, 1, 1 ignored. 1, 1, 1 ignored. This already done. 1, 1, 1 ignored. This is 1 and no 1. Okay, so this is the second condition. Third is the candidate is from the senior school and has height between 5 feet and 6 feet, but weight is not between the 50 and 60 kg. So senior school 1, height is in between 5 to 6 feet, H is 1, but the weight is not between 50. So 1, 0, 1 ignored. 1, 0, 1 ignored, already done. 1, 0, 1 ignored. This is 1 and this is 0. Okay. All others will be now 0. Okay. So till here, whatever is the question, the concept will remain the same. Now the question here has told, draw a truth table for the inputs and outputs given below and write the SOP expression for X, H, W, S, W, H, A. X, S, W, H, A. Write the SOP expression. Now since it is SOP expression, so I will write X, S, W, H, A is equal to sigma. I'll take all those values where it is 1. Had it been POS, then we would have taken all those where the values are 0. So remember always that whatever is the question, the truth table will remain the same. Right? The truth table will remain the same. Never get confused. That for the concept of truth table, again, if it is 1, we have to take it as 1. Even if it was POS, the truth table would have been like this only. Now, when we have to get the SOP expression, so it is X, SWHA. Now get the values here. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is what? 9, 10, 11, 13, 14 and 15. Right? We got this. So I hope till here it is clear to everyone. Next, now I have to make the K-map. Okay. 1, 2, 3. SWHA. Always whatever values are given, terms are given, use the same. So it will be S bar W bar, S bar W, SW, SW bar. Then H bar A bar, H bar A, H A and H A bar. 0, 1, 2, 3, 4, 5, 6, sorry, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Fine. 9, 10, 11, 13, 14, 15. 9, 10, 11, 13, 14, 15. So what will happen? I'll get one quad like this, one quad like this. Fine. So quad 1 is in between 9, 10, 11, 10, 11, 14, 15, 10, 11, 14 and 15. So this is S and H, and quad 2 will be 9, 11, 13, 15. So this will again be S and this is A. So X is equal to SH plus SA, and then you will make the logic circuit, right? So this is the question. So you need to understand this question very well, right? So this question will be covering your part of the Boolean algebra part. Now somebody was asking about okay. As you know, there will be one question from tree, right? If I say this is E, yeah. Now this is the diagram of a tree given. What is the root of the tree? A. Okay. If I am told to draw the left subtree of C, the left subtree of C. In that case, left subtree of C, left or right subtree of C. This we will draw this part, right? If I have been told to draw the right subtree of the root, right subtree of the root. So this will be the entire thing. Okay. Left subtree, this will be only there. Which are the leaves of the tree? B and B. B, D, G, H. We have B, D, G, and H. They are the leaves. Which does not have any child, they are the leaves. So B, D, G, H. If I have been asked what are named the siblings present in this pair of siblings present in this tree? B, C, D, E, G, H. One is BC, one is DE, one is GH. Okay. Then F, nothing. F is the parent of G and H and the child of E. A is the root. No, great grandfather. Great grandfather. Okay, now let's talk about the post order traversal. Post order. Always remember, in order, left, root, right. In order. Pre order. Root comes before. Root, left, right. Post order. Left, right, root. So let us talk about the post order traversal of this tree. We'll start with left, B, then we go to right. Right to extreme right, what is there? D, B, D, then we come again this side. G, then H, then its root. F, then its root. E, then its root. C, then its root. A. Right? Let us talk. So post order is clear. B, D, G, H, F, E, C, A. Fine. Then let us talk about the pre-order. Pre-order. Pre-order we will go with root, नहीं, root left right. So सबसे पहले root A, अब आ जाओ left B. Now you come to right. Right में सबसे right में root left right. Root left right. Root A. Now I came to the left. B. Now you again come to right. Right में when you come down, पूरा right. So here you have पूरा right. D. Right. D. Now you come this side again. So you have root left right. F, G, H. It's right. E. Then again you go root that side it is C. ठीक है. अगर हमको ये हो गया. Then I'm going talking about in order. In order. ठीक है. Left root right. In order left root right. So left we go B. Then we go to the root A. Then we come to right. To right you come here D. Then you come its root C. Then you go G, F, H and then E. ठीक है. एक एक यूनिट लेके हम चलेंगे. Okay. Then infix to prefix. Okay, address calculation. Address calculation, you must remember that address calculation, you have to always write the formula, whether it is pre-order, whether it is row major or column major, depending on that, first you need to write the formula and then you will be solving it and writing the answers accordingly. So formula writing is must. Then you will be getting one question. You might get one question in which there is a part of a function given, and in that function there are certain points labeled 1, 2, 3, 4, 5. So you have to find, like it is a fill in the blanks type of question. Here you will be finding that what will be the value stored there, right? You will be finding what is the value stored there, and you will be writing that. It can be a loop based question or it can be a method based question, and you could be asked. Then there can be one question where you have to find the output, and then also you could be asked that find out what is the value being taken here. Like if I say, I'll just take an example. This class display int GCD int A comma int B while In the loop is there. If A is greater than B, A equal to else B equal to now in this question, what will be the this is actually this is function. The following function is a part of a class which accepts two numbers and computes the GCD. If there is no common factor, then it returns 1. There are some places in the code marked as 1, 2, and 3, which should be replaced by a variable or an operator. Now, while the first condition A and B, what will be placed in between A and B? While A is not equal to B, if A greater than B, then A equal to A minus, it is A minus what? A minus B, else B equal to B minus A. Again, it is B equal to B minus A. So, first is A is not equal to A minus B, B equal to B minus A. It is finding the GCD, means dividing, that time it is finding the value. So, it is continuous subtraction method for finding the GCD. So, that is it. It could be again questioned that a part of a function is given and you could be asked that if a value is given, what will be the condition or what will be the value which result it will be getting, and it will be asked to find the value of the result. Okay, then again, if I say any doubts, any other doubts, students? You can type in the chat. Assertion reason question, you need to be careful when you are solving that, what is the logic there and what should be done. So assertion reason question, whenever you are doing, so that time you should be careful and try to understand the logic what is there, and based upon that you should answer, then only it will be correct, otherwise you might do it wrong. So solve those questions carefully so that you do not make the mistake. Yes, anyone, any doubt? Do not come up with any doubts tomorrow. What is the duality theorem? And to or to and, 1 to 0, 0 to 1. Okay. Go through all the Boolean laws properly. Okay. Sir, cover complexity. Okay. From complexity, you don't need to cover anything. You just need to remember the definition. You need to remember the parameters of complexity, space complexity, time complexity. Then you need to remember from complexity, you need to understand what are the best case, what is worst case, what is the average case, and then what is the best case, average case, worst case for different algorithms. That much only. It's a theoretical, just 1-2 page chapter. So means topic, whatever was I had given in the class notes, that much only is sufficient. Any other doubt? What is interface? Again, interface is basically a structure of the program. Like we can say a layout of the class. When we talk about a function prototype, this gives the prototype of the function. But when we talk about this thing, interface, the interface provides the structure of the class. So it gives an introduction. What are the basic parameters? What are the class? What are the various variables? What are the various methods used in the program? Those all things are specified in the interface. So to call a class, which keyword is used? Sorry, to inherit a class, which keyword is used? Extends. And to bring a interface, which keyword is used? Implements. Implements keyword is used to. So the interface keyword is used to call the interface. Implements keyword is used to call the interface of the class. So we will say class ABC implements ABC, XYZ you can say. Now, when we talk about the height of a tree and the depth of the tree. Now, the depth of the tree, depth of the node is the number of edges present in a path from the node of the tree to that node. So that is the depth. And when we talk about the height of a node is the number of edges present in the longest path connecting the node to a leaf. So 1, 2, 3, 4, 5, we count from the root. When we talk about the height of the tree, so the longest path, the number of nodes present in it, that is the height of the tree. हाँ? लेवल वो किस लेवल पे है? रूट को लेवल 1 पे रखते हैं, उसके नीचे 2, उसके बाद 3, like that. Logic gates conversion means what do you want actually? Which conversion? Universal gates or? No, somebody is asking 1 plus NAND to NOR. Okay, type of. I think I have explained it in that, no? I have explained it in that video of logic gates. You can go through it. I'll just explain once again, but again in detail you can go in that video of the logic gate. For example, this is a NAND gate. I want to obtain the output of AND gate. So this output I will divide into 2 parts and pass through another NAND gate. This output which will come, that will be the output of a AND gate. If we want to obtain NAND, using NAND, I want OR output. I'll take one input, divide into 2 parts, pass it through a NAND gate. I'll take another input, divide into 2 parts, pass it through another NAND gate. Again, take these 2 outputs and pass it through a third NAND gate, and this will give me the output of OR gate. So this is NAND as AND. This is NAND as OR, and to obtain NAND as NOT, what we do? We take one input, divide into 2 parts, pass it through a NAND gate. This will be NAND as NOT. Similarly, NOR as OR, NOR as AND, NOR as NOT we can do. And for detail, you can just refer to that video of the logic gates which I have uploaded.
YouTube पे लेक्चर डाले वो पढ़ लेंगे तो हो जाएगा.
लॉजिक गेट्स हो जाएगा, बूलियन अलजेब्रा हो
वही
जाएगा.
तो नहीं होता है लॉजिक गेट्स प्रोग्राम है. हाँ अच्छा सर, उसमें दिक्कत नहीं होता है.
Good.
पर उसमें आप मार्क्स कहीं कहीं ढूंढ ढूंढ के खाते हैं.
Any other doubt? We have 10 minutes around more. Recursion. For the recursion based programs, what we need to do, like for example, there is a function, like out of those functions, there will be like whatever question is there in that one function will be there in which you have to make that program, make that task or do that task using recursive function. For example, I take an example in which I will be using recursion to find okay. Then here I'm just taking a function like this is a program. Design a class perfect to check if a given number is perfect or not. A number is said to be perfect if the sum of the factors is equal to the original number. Now, in this case, what we are doing that the parameterized constructor is there, and then there is a function named int sum of factors int I, which will be using recursive function to find the sum of the factors. Okay? Other things will remain always the same. Input of value, calculating. So here I have a function named int sum of factors with int I. Int I. Okay, int I. Now this is a parameterized function which will be finding the sum of the factors, right? This will be the parameterized function which is going to find the sum of the factors. Now here you see, I'm taking the values if I equals num. I equals num. That's the value which is given. If I equals num, then we are taking here return 0. Right? Return 0. Okay. Then else if num modulus I equals 0. Else if num modulus I equals 0, then we are returning return I plus some factors I plus 1 else return
पूछ रहा है सेक्शन 3 में क्या क्या रहेगा
I plus 1. Okay. This is here. Outside again you will see if it is equal to 1, then it is the perfect number, else it is not a perfect number. See here, if I equals num, then it will return 0. If else if it is divisible by I, then I'm calling the function sum of factors I plus 1 again. So sum of factors I plus 1, this is a parameterized value, and again it is calling the next value. So I plus sum of factors I plus 1, else return sum of factors I plus 1. So within the function I am calling the function again and again. So that is a recursive function. So there will be one function for input, there will be one function for this, there will be one function for check. So in the function void check, if I say there will be a function void check, so there I can say I'll call the value int x is equal to sum of factors num. Now, if x equals 1, then perfect number, else not a perfect number. So this part will be there, which will be used to count the or call the recursive function. Whatever will be there, you will be using the. For example, I have to find the factorial. So if I equals n, return 1, else return n into fact of n minus 1. Right? So I'm calling the function fact within the function. For example, you have to calculate for the length of a string or count the number of vowels. So we'll call the function char of I, right? And then it checks the value there, and we check that character. If it is a vowel, then we'll update the value. So what we have to do that we have to call the function within the function. That is the basic concept, that wherever there is a function where you have to use recursive function. Remember, we do not need to use loops in that program, right? We will not use loops in that program. Instead of loops, we will use the if else part and check the condition. And then within that function, we will be updating the value. बस
सर तो जब जो आपका फंक्शन जो पैरामीटर है 8i उसको भी वो करना कॉल करना पड़ता है पूरा फंक्शन
इट इज अ पैरामीटराइज्ड फंक्शन तो फंक्शन के अंदर देयर विल बी अ वैल्यू सो दैट वैल्यू विल बी अपडेटेड ठीक है
सर वो I if I is equal to num
हाँ
मतलब I हम लोग का क्या चीज का वैल्यू है I हम लोग का
लूप का वैल्यू हम कह सकते हैं
और उसको हम लोग एक नंबर से कंपेयर कर रहे हैं
Right.
हम लोग नंबर लिया
जब तक वो सिचुएशन नहीं आ रहा है तब तक it will keep on calling and if that situation arises then it will exit
स्टार्टिंग में इनपुट लेते हैं ठीक
वो इनपुट मिल any other doubt anyone section C there will be one question from inheritance one question from stack means data structure that will be either stack or queue and then there will be one question where you will be getting tree and complexity. So one question from data structure program, stack, queue, linked list, anything. One question from inheritance where you have to make only the subclass and one question will be there from tree and complexity. Base class nahi banana hai, base class diya rahega. This is the base class. You have to make the derived class only. You do not have to make the main function. So we'll start with the class, subclass, extends, superclass. वहीं से start करेंगे. Any other doubt? स्वप्निल लिंक लिस्ट में अगर हम इंसर्ट कर रहे हैं एलिमेंट तो वी हैव 3 कंडीशंस देयर फर्स्ट कंडीशन ओके ठीक है अभी 2 मिनट का टाइम मेरे पास है वंस दिस मीटिंग एंड्स ना अगेन आई विल स्टार्ट विद द सेम लिंक ठीक है so you all could join again if the meeting ends I'll again start with the same link because after 90 seconds it will end ठीक है I'll keep this thing in noted linked list insertion anything else you could type नहीं हमको something like see if I have to insert no list in between this is a list this is a list and this is a list I have to insert a node in between these two nodes now what I'll have to do that this node was referring to this node right this node was referring to this node so the link for this now it will be whatever it was referring to so that node comes here so this will be made obsolete actually you have to insert so we get a node here this will be instead of referring to this will be referring to this and now this will be referring to this so it comes in between like if you are inserting a node in between so instead of referring to the other element next element it will be referring to the new node the temp it will be referring to the temp and the temp will be referring to the node of the current element that will be there ठीक है तो we'll just end it and all the best to all of you see you all